Fractions, decimals, and percent should be something that you are somewhat familiar with. Earlier in the year, we saw how decimals and fractions related to each other. So now we're adding the third part to this triangle of numbers called percents. You can see an example here. You already know how to do that 2 over 5 is equal to 0.4 because you divide the top number by the bottom number. And so today we're going to see how that is also equivalent to 40%. So here's an example. North Marshall has a box tops campaign going on. We have a goal of 30,000 box tops to be collected. So after Christmas, we had collected 12,000 box tops. There are 4 different ways that you could express this quantity. On the first number line, that says 3K, 6K, 9K, K representing 1,000. We have 12,000 box tops. So that's a little bit less than halfway to our goal. So you could express that as the ratio of 12,000 that we've collected compared to the 30,000 that's our goal. If you were to simplify that fraction down, it would go down to 2 over 5. You can see that that is the same distance on the number line. As a decimal, if you were to divide 2 by 5, you would get 0.4. And then as a percent, that is 40%. So first let's talk about decimals as a percent. From your vocabulary, you should know that a percent is a special ratio comparing a number to 100. Ratio, as you already know from this unit, is a comparison of 2 numbers by division. And what makes a percent special is that second number, the bottom number, will always be 100. It's a way of putting everything on an equal playing field. Think about your scores. You might have a lesson quiz that you got 2 out of 3 right, or you got 4 out of 5 right. But when you compare those two, well, which one did you do better on, the 2 out of 3 or the 4 out of 5? You can turn those into a percent. The 2 out of 3 would round to be a 67%, and the 4 out of 5 would be an 80%. And when you compare those, they're both compared to out of a number of 100, so it's easier to compare which one you did better on. So let's take the decimal 0.2. One way that you can do this is write it as a fraction, so 2 over 10, which would be 20 over 100. You can see that 2/10, if you say that out loud, 2 over 10, and then multiply top and bottom by 10 to get 20 over 100, which is 20%. To me, this is kind of the long way around. The easier way, which seems to be more of a mental math way, is going to be shown over here. You move the decimal 2 places to the right, and you add the percent sign. So if you're starting with the decimal 0.2, you move it over 2 places, 1, 2, and so I lovingly call these my loop-de-loos. You go bloop, bloop, and if you make that noise while you're moving the decimal, it is much more effective. So my decimal is now placed right here, and I have to insert a 0 in the loop-de-loo. So the decimal is no longer there. It's been moved to the back side of the 0. And so you can clean it up then. You add the percent sign. So that is equal to 20%. This can be done in your head. In the beginning, you're going to be using your pencil to move it over. But eventually, you're just going to be able to look at 0.2 and say, oh, 20%. Now let's look at fractions as percent. We've got 2 different methods here, and depending on if your number is 100 friendly is which method you're going to use. In elementary school, you use method 2, or even in 6th grade, numbers that divide evenly into 100. That was what the questions you would be given. And in 7th and 8th grade and beyond, you're going to be given values that are not 100 friendly. So I always like to go with method 1. What you do is you view the line in the fraction as a division symbol. You go back to what you learned earlier in the year about how to turn a fraction into a decimal, and you divide 4 by 5, and that's shown right here. When you do that, you get 0.8. And so then you change the decimal to a fraction, which is what I showed you in the previous slide. You move that decimal over 2 places, and it is 80%. Method 2 is setting up a proportion. Now, they may have not called it a proportion then, but now that you know about proportions, this can make a lot more sense. 4 over 5 is equivalent to a number over 100. We put an X there. So probably in elementary school, they didn't use the variable X. They might have had an empty spot or a question mark there. And if you'll recall from solving proportions, a couple of ways you can do that. You can cross multiply. 4 times 100 is 400. 5 times x is 5x, and then solve, and you get 80, and you put the percent sign on. Or you see, to go from 5 to 100, you multiply it by 20, so you do the same thing up here. 4 times 20 is 80. That works beautifully, like I said, when a number goes into 100 evenly. But think about the quiz example. A 2 out of 3, there isn't a number that you can multiply 3 by to get 100, not a whole number. So for something like that, method 1 is going to work better. To order rational numbers, you have a list of, let's see, 6 different numbers. And they're all kind of in a different language. You're seeing fractions, you're seeing decimals, you're seeing whole numbers, you're seeing percents, you're seeing repeating decimals, all kinds of craziness going on. So to order rational numbers, you need to rewrite the numbers in the same language. So here's some helpful hints for you. It seems to me that decimals are the easiest, to turn them all into a decimal. You could certainly turn them all into percents or turn them all into fractions, but even still, that's going to be more work, and you're going to be going back to the decimal form. And then cross them out as you use them, especially when you're dealing with a long list like this. You want to keep straight, make sure you've used all the numbers. In this example, there are no negatives, but if there were negatives, you're always going to list those negative numbers first. Picture a number line. The bigger negative is going to be farther to the left. So if you had -6, that's going to come before -2. There are no negatives in this case, so we're going to get to work to changing these into a decimal. So 1 and 4 over 5. To turn that into a decimal, 4 over 5. We've already done that one, and hopefully you have some of these memorized from the equal value sheets that we'll do as bell ringers. And I've told you once, I'll tell you again, the more that you have these common fractions memorized, their decimal equivalents, your life is going to be so much easier, because you can just look at that and know that is 1.9 as opposed to having to get pencil and paper and divide or getting a calculator. So 1 4/5 is 1.8. 0.3 repeating. It may help you to write it repeating a little bit. 1.6, well, that's already in a decimal. 3 is 3, okay. 2 and 1/5, that is 2.2. I know that one. If you didn't, you could take the whole number comes down and then turn the fraction part of the mixed number. 1 divided by 5 is 0.2. 70.2%. We're going to go backwards of what we did before of turning a decimal into a percent. So to go backwards, you're going to move that decimal 2 places over to the right, and that is 0.702. Now I'm going to rewrite these. So my least one, look at their whole numbers first. I have zeros as whole numbers here. 3 is smaller than 7. So my first one is 0.3 repeating, and I'm going to write it using the original language. Second is going to be this one over here. So 70.2%. Now I'm going to compare my whole numbers again, the ones, and then 1.6 is smaller than 1.8. Then I'm going to use 1 and 4 over 5. Then 2 and 1/5. And 3 is what's left over. You'll notice how when I crossed those out, it made it much easier. So let's say this was a quiz on the screen. You're going to want to rewrite that list so that you can write them and you can manipulate them. You can write their new language and cross them out as you're using them. Now time for you to practice a little bit. Take each of these and turn them into a percent, and then on part E, order those numbers from least to greatest. Okay, in part A, first I move the decimal over 2 spots. You can see that I annexed a 0. 0.6 is not 6%. Because you move it over 2 places, it is 60%. Think about that as 6 over 10. 6 over 10 would reduce to 3/5. That's more than half, so it wouldn't make sense for it to be 6%. It has to be more than half, 60%. For B, you don't just put a percent at the end. You move it 2 places so the decimal lands between the 4s, making the percent 54.4%. On C, I use the proportion method because 20 is a number that is compatible with 100. To go from 20 to 100, I multiply times 5, so I multiply the top times 5 and get 55%. On D, 5 over 8, 8 does not go evenly to 100, so I chose to use method 1, turn it into a decimal. You get 0.625, then move the decimal over 2 places, you get 62.5%. On example E, you've got original numbers that all have a 5 in there, but they are very different, so I turned them all into the same language, negative 0.5, 0.05, and negative 0.05. Start with the negatives first. Now, deciding which negative is different, think about a number line, and the bigger negatives are farther to the left. So if you struggle to compare decimals, it may be helpful for you to put another 0 there and think of it as 0.50 compared to 0.5. So 0.50 is farther into the negatives. Or think of it this way. Are you more in debt if you owe somebody 50 cents or if you owe them 5 cents? A 50-cent debt is greater. So that one goes first. Then my next negative, and then my positive 5%, 0.05, is at the end.